Math 3, Unit 7, Section 4. So today we're going to talk more about parabolas. This lesson is pretty much similar to the previous lesson 7.3 on parabolas. If you notice today though, previously if you look back, our directrix was a y equals value. And today you'll notice that it's an x equals. Okay? So what do you think this is going to end up looking like?
It's going to be like sideways.
Yeah, it's going to be a sideways parabola. Okay? So the same definition, a parabola is the set of all points equidistant from a given point and a given line. And so where would the vertex be on this one? 0, 0. Okay, so again, this is equidistance from the focus and also from the directrix. What's another point that we could put on here?
No.
Okay, and we're not going to like choose like the 5 points, but don't you guys remember one?
6, 3, right?
Yes, 6, 3 and negative 6, 3. Or wait, is that right? No, 3, 6, right? Out here. Because this would be
Oh, yeah.
6 and 6, right?
This graph is tripping me out.
Yeah,
Graph just
since
got
we're going
turned
sideways. So this is what our parabola is going to look like on here. So do you guys remember what about this distance?
What about the distance from what?
From the focus to these points here on the graph. This is called the focal chord. Do you guys remember that?
Mm-hmm.
So this line right here is still called our focal chord. And do you remember the distance that that is?
Equidistant?
It is equidistant from the focus. Remember that if this value right here is C, and this value right here, and we're going to talk about this in another minute, is C.
Oh, that's right. Yeah.
Right, this side is 2C, and this side is 2C, so the whole distance is 4C. Okay, what does the curve of best fit look like? We're just going to say a, and you guys already said this, sideways parabola. And we said the vertex was 0, 0. Okay, and we already know that the best way to figure out if a point is actually on the parabola is by using which formula? Distance formula. So we're not going to work through all that. We're just going to go ahead and write our equation. Okay, and so we write our equation doing the same thing as we did before. Okay, and so we want to find the point P, x, y, that will give us the exact equal distances. So our focus on this problem was 3, 0, and D equals a point on the directrix, and this time it's going to be negative 3, y. If you go back on the previous page, it told us that our directrix was at x equals, was it negative 3? Yeah. Mm-hmm. And so remember how in the notes for 7.3, they gave us y equals something, and so we put it in the y point or y part of the point. And so if they give us the x value, we know we're going to put in the x part of the point. Does that make it okay? Mm-hmm. All right. So again, we want to put that our point to our focus is the same distance as the point to the directrix. So we're using the point xy, focus 3, 0, point xy, director x negative 3y. Yes? Okay, so now we're going to use that information, plug it into our distance formula. Again, if you want to label these xy, xy, just to make sure you don't mess up. And then our first parenthesis, we're going to subtract our x's. So we have x minus 3 squared plus y minus 0 squared. Then we have x minus a negative 3 squared and y minus y squared. So when we simplify that there, we get x minus 3 squared plus y squared equals, on the other side, we end up with what? Good. X plus 3 squared plus, and y minus y is 0, so we have 0 squared. Okay, in order to get rid of the square root, what do? Square both sides. And so I end up with x minus 3 squared plus y squared equals x plus 3 squared. Say that one more time. I can't hear. In order to get rid of a square root, yeah, it only gets rid of, when you square it, it's taking care of this, not the other ones. Okay. All right, so now we have to multiply these out. And so when we multiply out x minus 3 squared, what do we get?
X squared plus 9.
Good. Okay, the other side, it's going to be the same thing, except for it'll be a, good, plus 6x plus 9. We know that anything that is like on both sides of the equation will what?
Doesn't.
So my 9's cancel out, and my x squareds cancel out. So we're left with negative 6x plus y squared equals 6x. What will I do now?
Add 6x. Yeah, add 6x.
Good. Add 6x to both sides. We have y squared equals 12x, and this time we're going to get x by itself. And so I divide by 12 to both sides. And so I have x equals 1/12 y squared. So what is different about this equation than the one that we worked with in 7.3? Very good. So this one has x equals, and the other one has y equals. So when you have x equals in front, you're going to have a sideways parabola. The parabola is going with the x-axis. And when you have a y equals equation, your parabola is going with the y-axis. Does that make sense? So it's curving with whatever it ends up being equal to. Okay. So, yes.
So on these problems, we're going to want to get x by itself?
Mm-hmm.
Okay.
Yep. Okay, so any point that makes this equation true will be on the parabola. Okay, and so on this one, I'm just going to write here, we would choose y values and solve for x in order to get the points on the graph. Where previously we would choose x values and like simplify and solve for y. So it's just the opposite. Okay, any questions before we move on? Okay. So this is the same thing, trying to now figure out, well, what is our generic equation? So that equation was just for the specific graph that we had at the beginning, where it had the directrix at -3 and the focus at 3, 0. So now if we don't have a specific point, we want to be able to write our equation. Can you guys guess what it'll be? What is it that we had last time? Do you guys remember?
Y equals 1 over 4c x squared.
So our guess is that the equation then would be x equals what?
1/4CY².
Yep. So I'm pretty sure that's what the equation's going to be. The only thing that's changing is our x's and our y's, right? So where this used to be y equals 1/4cx², for this one, when we're doing the sideways parabola, it's going to be x equals 1/4cy². Okay, so we're going to do the same thing as we did before. So we're just using any point that would be on the parabola. So we're using the point xy. And then for our focus and directrix, we're just choosing the value of c, right? And so our first point here, our point is xy. The focus is c0. Again, our point is xy. And then the directrix, so if this is going up c on the point, it's going to be a negative c, right? And then y. Okay, so we're going to use our distance formula. And again, if you like to label these, you can. Okay, so what am I going to put over here? Good, x minus c, and good. On the other side? Good. Perfect. Okay, so we simplify. We have the square root of x minus c squared plus y minus 0 would make y squared equals, we have the square root of x plus c squared, because two negatives make a positive, plus 0 squared, because y minus y is 0. Okay, how do I get rid of a root? Good, we square both sides. When we do that, everything just comes out. So we get x minus c squared plus y squared equals x plus c squared. Okay, when you multiply those out, if you want to use FOIL or the box method, you can. If you can do it in your head, you can. Do you guys know what it's going to multiply out to be?
X squared minus 6.
Okay, x squared minus 2xc, right? Plus c squared. Do you guys want me to show you the FOIL or box method for multiplying it out? We're okay? And then we still have plus y squared equals, and then over here we're going to get x squared what? Plus 2xc plus c squared. Okay, what are my like terms?
X
X squareds cancel out, and c squareds cancel out. Okay, and so to get like terms together, so right now I have negative 2xc plus y squared equals 2xc. So I would add 2xc to both sides. These cancel. Y squared equals 4xc. And then what would I do to get x by itself? Good. Divide by 4c to both sides. And so we get x equals 1/4c y squared, which is exactly what we thought it would be. Okay, so remember that 4c is the width of the parabola at the focus. So that right there is your focal chord. Okay, so it's going through the focus to each side of the parabola. That equals 4c. And then remember, c is the distance from the vertex to the focus, and also from the vertex to the directrix. Okay, questions before we move on? We're okay? All right, so let's do a couple examples here. Okay, so since this is x equals versus y equals, we know that it's going to be what type of parabola? Very good. So that tells us it's a sideways parabola. Or you can think of it as it's curving with the x-axis. So when it's x equals, it's curving with the x. When it's y equals, it's curving with the y. Okay, what would be my vertex on this one? Vertex is 0, 0. And what direction do you think this parabola will be going? Will it be curving to the right or curving left? Left, good. And why will it be going left? Because it's a negative in front, good. So let's make a point at 0, 0. And how do I figure out how much my C value is? Do you guys remember what we'd end up doing? Yeah, so you're going to go 4C equals 8. Yeah, you can do 8 or negative 8. It doesn't really matter. So we're going to divide by 4 to both sides, and C equals how much? 2. So remember that your focus is always inside your curve. And so which way would be my focus? Good, left 2. 1, 2, and that is my focus. And that's because we know the graph is going left. And then we're going to go right 2, and this is my directrix. And so the ordered pair for my focus is what? Good. Negative 2, 0. And what's the equation for the directrix? Good. X equals 2. Okay, and then how do I find my focal chord endpoints? How far do I go from my focus each way? It's 8 total, so we're going to go how much each direction? 4. So it's 1, 2, 3, 4, and 1, 2, 3, 4. Because those need to add to be 8, right? We also learned each of them are 2C, so if you double C, that makes 4. And so this ends up being my curve. And then those ordered pairs are negative 2, negative 4, and negative 2, positive 4. Okay, anything I need to re-explain? Okay, what am I going to do in number 2?
So whatever your C is, you just double that, and that's how far you go out from your target.
What am I going to do on 2? Good, divide by 2 because we want x by itself. And I know that I'm getting x by itself because it doesn't have a squared term. Okay? And so we end up with x equals 1/2 y squared. What will be my vertex on this one? 0, 0. So we can make a point at 0, 0. And on this one, my graph is going to end up going to the right. Good. How do I figure out my C direction? What do I write my equation as?
4C equals 2.
Good. 4C equals 2. So we divide by 4 to both sides. And what does C equal? 1/2. And so since our graph is going right, we know our focus is to the right. So we just go 1/2. And that is my focus. Then we go left 1/2 for my directrix. Okay, so we can write these ordered pairs. What's the ordered pair for my focus? 1/2, 0. And my directrix is a line, and so that's going to be, good, x equals negative 1/2. Okay, so if I double 1/2, or we know that my whole distance for my focal chord is just 2, how far am I going to go each direction from the focus? 1. So we go 1 to the right and 1 to the left, and that distance does make 2, which is what it tells me it should be here in my equation. And so the endpoints on my focal chord are at 1/2, 1, and 1/2 negative 1. Any questions? Okay, do you think you guys know how to write the formula for the equation?
Of the distance one?
So we use the distance formula in order to write our equation. So remember that a point, the distance between the point and the focus is the same as the point and the directrix. So what would be the ordered pairs for my point and my focus? So the point would be
-4.
xy, and the focus would be 4, 0, which they gave us in the problem. Okay? Now, again, my point will be xy, and I'm going to give you a minute here to figure out what are we going to put in for that directrix. So for me, I see that on the directrix it says x equals -4, so I know in the x spot it's going to be -4. And whichever point I don't have, I just write the letter. So in this case, I'm going to put what here? A y. Does that make it easy? All right, and so now we're going to use our distance formula. And so my first parenthesis is going to be what? Thank you, x minus 4 squared. Plus, the second parenthesis will be, good, y minus 0 squared. And then on the other side, we have the square root, and it's going to be, good, x minus -4 squared. Plus, and then y minus y squared. So when we go through and simplify, we have the square root, and it's x minus 4 squared plus y squared on the left. And on the right, we have x plus 4 squared plus 0 squared, because y minus y is 0. How do you get rid of a square root? Square both sides. And so we have x minus 4 squared plus y squared equals x plus 4 squared. When we multiply those out, what do you get for x minus 4 squared?
X squared minus 8x plus 16.
Good. Okay, and the only difference for x plus 4 squared is that we end up getting a positive 8x. Good. Okay, what are our like terms that I can cancel out?
X squared and 16.
Good, x squared and 16. So I have negative 8x plus y squared equals a positive 8x. Next I will do what? Good. Add 8x to both sides. We get y squared equals 16x. And then the last step would be to, good, divide by 16. And so my answer is x equals 1/16 y squared for my equation. So looking at that equation, what is my focal distance? Focal chord distance.
It's 4.
16, and you'd go 8 on each side. And then what is my C value?
8. I mean 4.
4. So we'd go right 4 and left 4 for our directrix and our focus. And then would this parabola curve right or left?
Right.
And how do you know?
It's positive.
It's a positive. Good. And is the focus inside the curve or outside the curve? Inside. All right. Questions? Yes? No? No questions? Okay.